This is part 1 of lesson 3, which corresponds to chapter 3 of Network Security Firewalls and VPNs, and it discusses VPN fundamentals. Our learning objective is to describe the foundational concepts of virtual private networks. The key concepts are the essentials of VPNs, VPN connection encryption, VPN transport and tunnel modes, the roles of VPN appliances, edge routers, and corporate firewalls, and VPN models and architecture necessary for implementation. Here we see a virtual private network, a remote laptop trying to connect to an authentication server and then from there into the internal local area network across the internet. It is a secure encrypted tunnel across the internet between an authentication server sitting outside the internal local area network and the remote user who wants access to that local area network. So what is a VPN? It is a computer network that uses the public telecom infrastructure, in other words the internet, to provide remote access to secure private networks. It allows organizations to privately transmit sensitive data remotely over public networks. It secures communication between separate private networks through what's known as tunneling. As you see, there's a VPN tunnel in the middle across the internet. And it protects sensitive information transiting the public network. A VPN is a low-cost alternative to leased-line infrastructure. It delivers remote connectivity to offices and workers. Leased lines create a direct and permanent path between two locations. They provide wide area connectivity by way of reserved connection for private customer use. Dedicated circuits that provide there are also dedicated circuits that provide the last mile access from user premises to the internet service provider. So VPN is a low-cost alternative to this. It supports the internet remote access, in other words, remote office and telecommuter, local area network to local area network internetworking, home office and satellite offices, and controlled access within a network, mobile users and desktop users. It provides remote access and remote control and employs encryption and authentication for secure transmission. It employs encryption and authentication for secure transmission again, and there are restrictions for mobile users that ensure a baseline level of conformity and security. There are several different VPN deployment models: true, trusted, secure, and hybrid models. You need tailored VPN security to match your organizational and data privacy needs. You can establish control over components such as software and hardware, conversations, which are endpoint connections, and communications, which are network infrastructure. Customers and providers may separately manage and maintain devices. Customers may outsource different aspects of VPN ownership and operation to service providers. And you can custom tailor ownership and operator responsibilities to budgetary needs. Network protocols. Tunneling protocols package packets within packets for secure transport. Transport protocols package payloads within packets. Encapsulating protocols wrap around the original passenger protocols, and carrier protocols carry the package VPN packets. There are various different VPN protocols. IPsec was originally for IP version 6, but is widely used on IP version 4. Secure Sockets Layer (SSL) and Transport Layer Security (TLS). Datagram Transport Layer Security (DTLS). Microsoft Point-to-Point Encryption, and Secure Socket Tunneling Protocol (SSTP). VPNs bridge distant connections. They bridge the connections between home and satellite offices. They may span separate cities, states, countries, geographic territories, and international borders. They can share private local area network and intranet resources globally. Suppliers and distributors may maintain a separate private network for product sales and purchasing or parts ordering. At organizational headquarters and satellite offices may share common directory services, informational databases, supply chain resources, and other items. They provide varying levels of granular network access to separate locations. Client-server connections focus on user profile permissions and restrictions. Multiple site-to-site connections apply user policies and network controls. VPN clients are browser-based in executable formats. And VPN servers can integrate into routing devices and network appliances. VPNs maintain confidentiality and integrity for users and data, part of the CIA triad. Confidentiality is maintained inherent in the VPN because of the encryption of the data passing along through the tunnel. And integrity is maintained because it ensures that all of the data is transported from point A to point B. Some advantages of VPNs. Corporations can save on lease line costs with a virtual private network, which was pointed out before. They eliminate the need for long-distance lease line connectivity, as pointed out. They reduce long-distance telecommunication charges, and they can offload support costs or outsource to network operators. Scalable network arrangements are possible with a VPN. Branch offices can deploy readily available VPNs. VPNs can scale from a few nearby offices to several campuses around the world. But there are drawbacks of VPNs. They suffer from the same congestion, latency, fragmentation, and packet loss as any other long-distance connection experiences. They have difficulties with compliance and troubleshooting. Encrypted data traffic does not compress because it lacks repeating patterns and is therefore more bandwidth intensive than clear text transmission. VPN connectivity requires high availability for constant uptime and accessibility. So these are just some of the various different drawbacks of using a VPN. There are various VPN security and privacy issues. They cannot ensure the quality of service or complete security. VPN links depend on availability, stability, and throughput of the Internet Service Provider connection. They're not an ideal connection method for dial-up modems or low bandwidth links. Infected mobile users can potentially damage or disrupt the private network. And confidential data can be copied outside the boundaries of internal controls. VPNs are not a cure-all solution. They require upkeep, updates, and upgrades just like any other network. Clients must maintain baseline levels of safety and security. Servers must maintain current fixes and patches for software. Administrators must maintain software updates and hardware upgrades. VPN clients are harder to keep compliant. Roaming profiles are more challenging to maintain than local user profiles. Offline users can tamper with systems or bypass some restrictions. Careless or defiant users may compromise systems and threaten the network. Varying VPN client server setups provide inconsistent security provisions. Amongst these are true VPN. A single organization owns all the network infrastructure. That would be ideal. Trusted VPN controls communication pathway but doesn't prevent eavesdropping, and so that would be some inconsistent security there. A secure VPN-T uses public networks but does not control or ensure the transmission path, more inconsistent security. And lastly, a hybrid VPN is a secure VPN over a trusted VPN connection. That would provide more security, but overall, from one type of VPN to another, there is no consistent baseline of security available. VPN endpoints. We have host computer systems and edge routers, corporate firewalls, and dedicated VPN appliances. Endpoints can terminate at a host computer system, edge router, corporate firewall, or dedicated VPN appliance. They provide secure remote access, site-to-site connectivity, in other words, for example, college campuses, host-to-host networking, and an extranet, for example, distributed to a supplier. They operate in two modes of encryption, encapsulation. Tunnel mode protects the entire packet from header to payload, whereas transport mode protects only the packet payload. In Part 2, we will discuss VPN appliances and architectures, and how VPN sessions are created and connected.